Okay, so we're going to try to illustrate this thing called correlation coefficients. So in this case, I have prepared already what you need to look at, which is the formula for correlation coefficient. So if you look on the right-hand side, so if when we do go through this formula, which I have to show you how to do, but if you get a number that's closer to 1 or -1, both are good because they both will show that it's a line. Both if it's 1 or -1, the more likely there is a correlation between the two sets of data. So we're going to use the bed data and the bed and hospital data that we used in video 30. There were 10 hospitals with the number of beds and the number of personnel. You have to go back to video 30 because I can't get it all on one video. Don't have enough time, for one thing. So the closer we get, this formula gets us the number of 1. That means the more likely that we have a or -1 that we have. There's a correlation that the two are related, and the further away it is from 1 and -1, the less likely. Okay, so how does this formula work? Let me show you. There's an n here, and that means you go back to the video 30, and you look up the amount of data pairs. There were 10 of them, all right? There were 10 beds, 10 hospitals, so the amount of data pairs, there were 10. So a 10 is going to go in here. What about this x? That's the sum of the x's. If you go back to that video, you'll see that the x's were the beds. That was the x-axis, and the y was the amount of personnel working with the hospital. So take all the x's, the 10 x's, add them together. That's what this means. Sum them all up. Add them all up. Add them all up. And what about xy? Multiply x times y. And then all the x times y's, there's 10 pairs of xy's, multiply them all 10 multiplications, and add them all up. And what about x squared? Take the number x squared, take the number y squared, and add up all the x squares and all the y squares. There was 10 situations with beds. You add up all the 10 x squares. There's 10 situations with personnel. Add up all the y squares. That's what this formula is doing. It's not such a big deal. Take n, which would have been 10. I remember that number. Add up all the xy's, and then subtract from there, adding up all the x's times adding up all the y's. Then the fraction bar, it's a division. Square root of this whole big thing. 10 times adding up all the x squares minus adding up the x's and squaring them. Be careful, that square's outside. This one's inside. Then 10 times adding up all the y squares minus the adding up the y's and squaring them. Again, the square's on the outside, this one's on the inside. That's the formula. Okay, so sum of the x's, that means sums of x, add up all the x's, add up all the y's, do x times y 10 times and add them all up, all the x times y's, add up all the squares of x's, there's 10 x's, square each of those x's and add them, square each of those y's and add them. Okay, where does that lead us to? That leads us to here. It takes us to this, and I couldn't get this all, write this all within 15 minutes, obviously. So they did it for you. Well, I've got it all done. I've taken an example from a book. That's exactly what I need. And here are all those 10 beds. Here's all those 10 personnel. Remember the 366 people in that last hospital? So adding that, this symbol means add them all up. This symbol means add all these up. Take x times y, meaning 28 times 72, and you get this. There, you do that 10 times, and you add up all of these numbers. You get this number. You take x squared, which means you take 28 and square it, and here's what you get, 784. You do that for all those numbers, and you add them all up. You take y squared, which means you take 72 squared, you get this number, add them all up, and you get this number. You can see it even though it's a little bit unclear, 372,814. What do? You plug those results into the formula. The number n is 10. That's the 10 situations, right? There was 10 data items, 10 pairs of data items. The sum of xy, just look it up, it's right here. And move it in. Then comes a minus, then sum of x, look it up. Look, it says 572, put it in. Sum of y, put it in, 1750. This one, square root, okay. Now n is 10. Sum of all the x squares, look it up, it's right there. sum of the x's there and square it. The 10, that's n again. Sum of all the y squares, look it up. It's there. Minus what? Minus the sum of all the y's, look it up. It's right there. And square it. You get this after doing the calculations, and then you square to this. You got to use a calculator, and you get 0.748. That is your correlation coefficient. It's getting close to 1, so that shows you it's pretty close to 1. It's relatively close to 1, so that shows you that there is a correlation between the beds and the amount of personnel. It's not perfect, but it's got a lot of exceptions. But that's a number that's relevant. That shows you something. Okay, that is the story here. So let's end this video. Let's get back to here and stop the recording.